It's absolutely lovely to be here. It's obviously not a cold, damp castle, though I'm sure you've got wonderful castles here. And it's really turned into a fabulous conference series, and it's exciting to be part of it. So I'm going to be, first of all, I'm going to be talking about functional programming, which is what I do for a living. I'm the designer of a functional programming language called FSharp. I'm going to be talking a little bit about FSharp, and what I'm going to be talking about is implemented in FSharp, but I'm trying to draw out the whole theme of the relevance of functional programming to the user interface and the app development at the front end. And it is a theme that's applicable in many different programming languages, including JavaScript, including TypeScript, including Elm. Many different programming languages are heading in this direction, and I want you to be aware of it, not just in its FSharp manifestation, but as a general trend on the front end side of things. This is the work here has been contributed to by many, many people. Timothy Lariviere, and the others I've listed down below. And a huge thank you to everyone who's been working on the different frameworks I'm going to be talking about today. Now, I am here for another reason. So you'll all be coming to the conference party tomorrow night, I hope, where I get to play bass in the fantastic, wonderful Dylan Beattie and the Line Breakers. And I am mentioning this for a reason, because I'm coming to the opinion that software, lessons about software are perhaps best communicated through song, through music in many ways. I'm not going to sing for you. I will play music for you tomorrow night, the bass guitar. But there's something about Dylan's music that does a magnificent job of bringing out things we perhaps don't normally find that easy to communicate. And one of them is this simple song, which you're going to absolutely love tomorrow, if it plays. This one play? Got some sound there? I've got something plugged in. Maybe we got it plugged in the wrong spot. I can skip this part. You get to hear it tomorrow night. The song is "We're Going to Build a Framework," and it's to the tune of Billy Joel's "We Didn't Start the Fire." Okay, and you all know the lyrics to "We Didn't Start the Fire." It goes on and on and on and on through the 50s, the 60s, and 70s, and the 80s. Everything that happened in those in the politics in those different eras, and it goes on and on. And in this song, Dylan goes through all the different frameworks that people create, and it just goes on and it goes on and it goes on. And the lesson for me in the song, the principle it's kind of drawing out, is that frameworks are like a river, okay? You know, they just keep coming, okay? Frameworks are not an eternal thing, okay? The principles that underlie a framework might be an eternal and recurring kind of mathematical kind of thing, but frameworks themselves, you've got to make them, you've got to love them, you've got to hate them, and then you've got to let them flow by, okay? So, and I'm mentioning it because this is about me entering into the world of making frameworks. A programming language lasts a very long time. When we make programming languages, they tend to hang around for 20, 30, 40, 50 years or more. But when we make frameworks, we expect them to have a shorter lifetime, but we want to understand the ideas that underlie the frameworks as well. Okay, but it is in the context of FSharp, and my main work is about the FSharp programming language. So I'm going to tell you a bit about FSharp to give you some context, and it should just take 5 minutes. So first of all, if you're into history, okay, if you're into knowing where things come from, if you're into stories, then as I am through the music as well, then please go and read fsharp.org/history. This is the second draft stage now of the History of Programming Languages submission on the early history of FSharp. And it's a wonderful rock and roll 40-page read from the 1970s through the 80s and the object-oriented tidal wave of the 1990s. And I shaped the story in a way that we have Microsoft and we have academic research in functional programming languages, completely different separate universes, both making their ways through the 80s and the 90s. And then they both get like wiped out by this thing called object orientation. This tsunami hits both of them. These functional programming people have been living in their happy theory world, and suddenly they're going, oh my God, objects don't fit into our lambda calculus point of view. What on earth do we do about this? And Microsoft, this huge enterprise, a monopoly position in the world, gets hit by the sort of Java thing, and these people respond in different ways. And Microsoft, one of the responses they make is to create .NET. And one of the responses that these academics who end up working for Microsoft Research make to the world of object orientation is to say, oh look, .NET, functional programming, maybe we can make these things work together. Yeah, you look at Scala, it's a similar reaction. A lot of what we use and take for granted today is all a reaction to functional ideas combining with object-oriented ideas. You look at what's happening in C#. We're still working through this combination of what does it mean to combine object orientation and functional programming. And certainly that's at the core of the F# design. How do we take the goodness of functional programming and make it real in the context of in a sort of industrial ecosystem and runtime and library design and so on, like .NET. So that's really what the early history of F# covers. Please do give it a read. And there is still time to send feedback and tell me all the things I've missed out. So please do that. So what is F#? As far as Microsoft is concerned, if you go and look at their front page, this is how they describe it: the open source cross-platform functional language for .NET. So we sort of achieved what we set out to do back in the early 2000s, which is to make functional programming relevant to the .NET platform, and here it is. It's also, we've achieved that through additions to C# as well. For those of you who use C#, you use our work every day that came from the research labs back then. But it's interesting because F# isn't just about .NET, because you go ask the F# community what F# is about, and they'll say, actually, F# is a JavaScript language. Okay? And this is Fable is a JavaScript compiler for F#. There's also WebSharper, another JavaScript compiler, but I'm going to talk about this one today. It's powered by Babel, it produces readable standard code, and it's very much part of the JavaScript ecosystem. You install Fable by a set of node packages, NPM packages. And you can use Fable in the browser without any .NET, so it cross-compiles the whole F# compiler into JavaScript. And from this perspective, F# is a JavaScript language in the same way TypeScript is a JavaScript language. I just want you to know that you can approach F# from a non-.NET perspective, effectively. You're doing F# programming in the context of the JavaScript ecosystem, and it's got quite a different feel to C# in that way. When we think about F# on the web front end, this is what we think about, Fable and also WebSharper. We don't think about Blazor so much, for example. There are people in the F# community who are interested in bringing F# to WebAssembly and F# to Blazor. But we already have a fantastic experience of using F# with JavaScript, so you can just approach it through this route. Okay, but what about F# at the back end? Well, of course, we use ASP.NET Core, and we tend to use a very small library that sits on top of ASP.NET Core called Giraffe. It gives the same performance, incredible performance results as ASP.NET Core, because you're using ASP.NET Core underneath. I'm not going to show any examples, but there are lots of examples under the Giraffe repo. It's just really nice, simple, declarative code for functional processing of web requests, and sort of it's a really sweet back-end implementation system. Okay, but today's about F# for the front end. Just a little bit more about F#. It's open, cross-platform, neutral, and independent. All the language is accepting contributions. The community is very self-empowered through fsharp.org, the F# Software Foundation. We have the Xamarin tools for the mobile platforms, Android and iOS and so on. We have Visual Studio editing tools all over, and of course .NET Core on Linux and OS X. Underneath it all, we have the F# compiler service, a single library, a single DLL, which contains really the whole implementation of F#. It's used in JetBrains products, it's used in the Microsoft Visual Studio, it's used in Xamarin tools or Visual Studio for Mac, and that's the part that's used in Fable. and it cross-compiles to JavaScript, and that's really the core component that is FSharp, really. I've mentioned Fable. There's a full stack version where we take Fable on the front end and .NET FSharp on the back end and put it together in a thing called SafeStack. It's a really wonderful system for getting involved in full stack FSharp programming. And now we've actually finished FSharp 4.7. This slide's need an update. So this setup here really lets me focus on my job on the language design, which is down in this corner, and also on applying FSharp, in this case, in UI and app development. So our aim all the way through culturally is to combine enterprise readiness. Of course, it's a Microsoft deliver this as an enterprise-ready tool chain, but it's a community-centered approach to how we conceptualize the FSharp community. We don't have Microsoft separate to the community. Microsoft contribute as part of the community. Microsoft do have a special role. We act as gatekeepers for quality control and sort of by agreement with the community. And at the heart of the community is fsharp.org, the FSharp Software Foundation. And there are FSharp conferences run by the FSharp community. You can also, of course, see FSharp and lots of other events such as this one. We have a language design process. I won't talk about that much, except if you want to get involved in the RFCs or make suggestions or help implement them, this is the place where you get involved. There are several features of FSharp have been proposed by the community, designed by the community, and implemented by the community all the way through. And so you can get involved and make a direct contribution to this language. I'll just really skip through these, just let you scan your eyes over them, of the things that have come through on the language design side. Span support for async debugging, anonymous records, and FSharp 4.7 just come out, Lang version, implicit yields, and indentation relaxations. Okay, the community are very involved in tooling. The Visual Studio Code support for FSharp is packaged and delivered by the community based on the components I mentioned before. This gives you FSharp editing, cross-platform, and with all the language service things we know and love. To get started, all you have to do is add that magic -lang FSharp on your .NET New line. It's for FSharp on .NET Core, .NET New -lang FSharp, .NET Build, and you'll be away creating FSharp libraries. Okay, so that's all positioning a little bit about FSharp, and I want to talk the real talk. So when I talked about history, the paper covers sort of what we thought FSharp was for when we, about bringing functional programming to .NET and so on. We were really thinking of it as embracing this idea of functional first programming. You start your coding with you code as much as you can in the in functional programming, and then you use object-oriented programming or mutation-based programming where necessary. But one thing we lacked in early FSharp was any really strong opinion on functional first UI and app development. I mean, I think I made a mistake here, right? I should have had a stronger opinion on what functional first UI and app development was about. And it's really not until the advent of a language called Elm for web programming that the functional world has really been shown just how relevant functional concepts are in the user interface space. So in many ways, we're playing kind of, this work is about making up for past mistakes or things that we missed from the past. I mean, at the time we did FSharp, there were these big frameworks like Windows Forms or WPF, and then things like Xamarin come along, and they're all very object-oriented, very based on the user interface as this mutable state. And so it didn't seem like there was a big place for functional programming. But things are changing. So most of those big frameworks I just mentioned are what we'd call model view model frameworks. And old things like GTK, Xamarin iOS, WPF I've mentioned, Android, UWP, Xamarin Forms. And also, if you look at Apple frameworks, it's Android frameworks and the like, they're also over here on the left. Now there's this new wave of things coming through, which is really what this talk is about, which is model view update. And there are things like Redux, Flux, React Native, React, Flutter, and Fable, and Elm. And it's no coincidence that over on the left you've got these old-fashioned logos, and over on the right you've got these new kind of logos. And in fact, no coincidence that these logos all kind of have this notion of sort of flow in the visual design of most of them. Swift UI has a strong feel of this sort of thing over on the right as well. And over on the left, these frameworks, definitely object-oriented, complex, mutable models of the user interface DOM effectively. They're usually combined with some sort of declarative static UI, often in a second markup language. Okay, and often that's done to support some designer tooling, which when it works is great, but when it doesn't, it adds, well, certainly no matter what, it adds a lot of complexity to your overall tooling stack. Okay, that presence of those designers. Over on the right, it varies a bit, but they're definitely much more functional. They generally use simple declarative models of the user interface. The UI tends to be declarative, but it's also crucially, it's dynamic. Okay, the UI changes extensively over time. It might change whole modalities over time. The view generally, it's not always, these are different bits and pieces of the puzzle, but if you look at something like Elm, the view is expressed in the same language in a DSL, and they usually rely on live coding tooling rather than designer tooling. Though you can in theory do designer tooling over on the right, it's usually just based on live coding. Okay, so right, so what's the sort of difference? Over on the left, you've got view, you've got the view written in something like XAML. You've got some strong notion of data binding here, sending changes back and forth. You've got a view model, which is an object-oriented, mutable object-oriented thing. And then you've got an underlying business logic and layer. And all the time, there are mutations and signals and events firing, which cause some mutation either on one side or the other. Okay, over on the right, it's a very different, and it's why you have this flow kind of thing. You have a model which is implemented in immutable data in the most extreme version, in the Elm architecture, for example. You render that using a function called render, which simply takes some data and computes a view. The render can be thought of as a pure function. It just takes some data, which is the model, and gives you the data, which is, think of it as the HTML if you like. You can think of it as just sort of generating elements in a DSL, but it gives you an immutable description of the view. And then the view things happen, messages happen, and you call the update function, which gives you a new model. And information only flows in this direction. This is functional, and this is functional here. Okay. So that's a very different architecture, and it's a very principled approach to how information, representing the information flow in a user interface. Okay, so let's talk a little bit about MVVM, and let's talk a little bit about XAML. This is that designer thing, and I want you to just kind of look at what happens in XAML. And this is in common with many other things. I'm not assuming everybody here knows XAML, but you have a sort of tree of things, and you have attributes on the tree. And then you have these parts, curly bracket binding path equals string format this. And this is saying that when we bind to some bit of the view model and we put it into the user interface and add in a little bit of computation to, for instance, format a value, here's the point where we bind to, and here's a little bit of formatting we can do on the user interface side of things. And you'll see lots of different bindings going through there in various parts. Okay. So what's the problem with XAML? Why not do it this way? So XAML is assumes, it's all based around this idea that you'll have these people called designers who'll work on XAML, and you have coders who'll work on the underlying view model and business logic. And in fact, originally when it was conceptualized, you were going to have a whole different tool chain called Blend, which is going to be used for design, and you'd have a whole different, and then of course you'd use Visual Studio or some sort of coding tools for the underlying code. So you'd really slice it off as a separate activity into a separate DSL because the people were different, have different needs. Now there's valid reasons for that approach, but it causes immense problems, okay? Because XAML is static, okay? Well, you can add these dynamic bits about how to format things, about how to turn elements on and off. You can add things like templating to give dynamically sized lists of things. And then you start to add in all these code-like constructs. You add in behaviors, you add in converters, and then you add in the designer tooling, which every time you add something that's code-like, like a behavior or a converter, well, then you need the designer tooling gets more and more complex, and the mental model of the designer's world has all these weird things like converters, which are very different language to what's actually in the underlying code. Okay, so to me, XAML is a little bit like trying to take the skin off your body, okay? And then still have a living, and then design the skin or something like that, separate to your body. But it doesn't work like that. You end up just creating a huge amount of complexity or mess or blood or whatever else if you try and rip apart these things, which in some way have to interact and be dynamic together. So for me, XAML stems from a fundamental category mistake made way back in 2003, that dynamic UI should be separated into a static markup language. And now you can do XAML and MVVM in FSharp. You end up writing a class and you have some mutation and you have an implementation of some objects and this, and it's just incredibly object-oriented FSharp. If you need to do it, if you need to do XAML and FSharp, you can do it. But let's take a look at how it just doesn't seem to fit very well with the functional paradigm. But let's take a look at MVU. And the whole point about MVU is best your UI is an incremental computation. You have this flow flowing around, and the crucial thing, of course, you reevaluate the view, but you don't go and make a whole new view. You don't throw away all those user interface elements that underlie the system. You just do the React thing and apply a delta to the actual DOM. So you create a virtual DOM, and you're happy to sit there and recreate that lots and lots of times, but you only apply a delta to the actual DOM. There's slides from Yaron Minsky at Strange Loop last year. I'll come back to that. Now you might say, okay, that all looks really good, but we're still reevaluating the view on every change to the model, and we'll be talking about that more lately. You might think, does that add up? Is that a good thing to do or not? But let's take a look. We'll come back to that question of performance later. So this is what an MVU app looks like in FSharp. You have some model, you have some. Now this corresponds architecturally to that exact flow diagram that we had before, the exact pieces. So the architecture is very, very regular. You have an underlying model, you have messages that indicate possible changes to that model, you have an initial state, an initial model, you have updates to the model. That is a functional programming. You take an old model in and you get a new model out. Underneath it might share some nodes or whatever, but they're both immutable data, immutable model to immutable model. And then you have a view function, and you compute the view. And I've put an if then else in here just to show that it really is computed, okay? For instance, if we're logged in, if we're not logged in, then show some initial screen, otherwise show the actual information. So even this sort of conditional is hard to express in XAML. You've got to put both screens, or both, assuming we're still using one page, you've got to put all your elements flattened and put control knobs to turn them on and off. Whereas this just takes the functional programming approach, if we're doing, of using computation for the view rather than this static data. Okay, filling that in a bit, we might have a model which has a simple flag, has a button being pressed. We have a single message here, the message is causing updates. We start in the button is not pressed. When the button is pressed, we present a new model. if the button is pressed, and say a label that I was pressed, and otherwise say, please press me. Nice and simple. The view is just computation, the update is just computation, everything's functional. So sometimes people think functional programming is just about using the odd little lambda here and there. But this shows you can take the functional programming ideas of everything being a function, and at the very top, you wire them into some system which actually manages making sure we've only got one of these states, but there's only one bit of state really around, which is the model, and then we generate the view, and a little bit of code for doing the differential update to the actual DOM. But from the user's point of view, everything is functional programming, and then somebody else looks after the process of wiring the functions up and making the actual application. So it's all just functional programming, and by that we really mean it's all just calculation. Sometimes people think functional programming is a scary thing, but they use Excel all the time. Excel's just calculation using formulas, right? And so that's what functional programming is. We have some data, you have some model, calculate a view. We have an update signal coming in, like the button was pressed, give us a new model. It's just calculation, and we can all do that. We've all been doing that since at school, since we were grade 3, we learned how to calculate. UI becomes calculation and information flow, not about mutable state. Views are recomputed and differentially applied. So MVU and its variations are becoming almost ubiquitous. You see new things like Svelte is very interesting. Fabulous, I'll talk about today. Swift UI has a lot of these kind of ideas in it as well. They're not all full MVU, but a lot of these have ideas from it. This is, there'll be differences. Your view DSL might vary. This is the view DSL we use for Fabulous, which I'll be talking about more in a moment. FSharp MVU for mobile, sitting on top of Xamarin. And you'll see we use view.label. In MVU for the web, we see it a little bit differently, which is that the DSL here uses div and button, the HTML kind of elements that you expect. And then a DSL for putting attributes on those and styles and so on. And this is Fable, I mentioned before. This compiles to JavaScript and runs as JavaScript inside a web page. So it's MVU for the web view. Okay, so let's just talk about problems with XAML again. If you go to, sometimes you have a simple problem that your view model is giving you a Boolean value, but you need to negate that. You need to turn true to false and false to true, and you need to do that in the view because you don't want to go change the actual underlying code. So somebody goes and asks, how do I do a not in XAML? Okay, I don't know, this is the bit I don't know how to do. And the answer is what you want is a converter. Okay, you have to install a library of converters called the negate Boolean converter. And then you actually use, you have to put it, the converter equals curly bracket static resource inverter. And then you have the actual negate Boolean converter somewhere underneath in your code. Okay? I mean, this stuff really makes my head hurt. Okay? And it turns out the answer wasn't right, good answer, but someone who's not too familiar with XAML, they need to add a namespace in the XAML file to get the converter and so on. Now let's look at how that looks in the MVU world, where views are just calculation. Okay, here's a view function, and you see it? You see how hard it was? I'll flicker back. There we go. Not. So let's say you have model.changed and you want to do it to not unchanged because someone has changed the underlying code and you've got to match it on your side. Well, yeah, can you execute the button? Well, you just compute. No, yes or no. You based on what the current model is, because you got to reevaluate this on each time the view comes around. So you can just use a not in here directly, and that'll give you the right state for the can execute button. So because views just become calculation, you don't need any of that stuff like converters. You can throw away, you can just forget all these things, that this split of splitting the skin off, all this complexity that caused, because it was never, all you're doing is applying a function called not. right? And that's how you code it. How easy is that? Okay, so that's the concept of MVU, and of course you've got to make it real in one of those frameworks that come and go with the flow of the river of life. And yes, so we put together this framework called Fabulous. You get started just by installing the templates and then doing new Fabulous app and give it a name. You build it and you've got an app that has a few simple controls on it and and a view you can play with. And then you can deliver that app as an Android app or an iOS app or a GTK app or a WPF app or Mac iOS and several others. And I'm not going to give a live demo of using it today. I sometimes do, but I thought I'd just not do that today. And this is the original version of the kind of app that you get and deploy based on using Fabulous. And you can do live update. There's some live update tooling. So this is running a visor looking at my Android device. And you can make edits and save the file and then develop the app incrementally directly. And it will replace the view function, replace the update function, replace your model, and then the app just continues. Okay. Okay, so cool. That's the core of Fabulous. Of course, you need to still address the fact you have to do really good user interface design. And I'm not a user interface designer. But of course, there are people who do it, and the way you do that in the context of Xamarin is with CSS. You can just use all of CSS3 in the context of Xamarin controls and style, and your designer spends most of his or her time writing CSS3. Okay, so here are some sample apps built with Fabulous. I'll be talking about Fabulous contacts on the left. There's a game on the left. You can integrate third-party components such as 3D rendering in the sample in the middle, maps and charting, and so on. Okay, so let's talk about Fabulous contacts. This is a sample app that is very full-featured. I've got my slides a little bit out of order. In a moment, I'll run through the parts that are covered by Fabulous contacts. I'll do that just at the end. But if you want to learn about sort of the real-world process of using maps and of using web API calls from your front end, handling errors, then handling multi-page applications, then Fabulous Contacts is the place to start. You can just duplicate that out and get going with multi-page Fabulous apps. Okay, but question is it fast enough? Okay. Because we're using view reevaluation. Every time the model changes, we reevaluate some code, allocate some objects, and do a diff on them to check if anything has changed, like that button state had changed. Okay, so now it turns out that's actually fast enough for nearly all information-based apps that don't have high update rates. If your app is really just about information and not about fast update, then simply reevaluating the view will be absolutely fine. Okay, and that's the reason why React works so well. It's the reason why Elm works so well. So for many purposes, what you do is already fast enough. But it can be that you want to avoid reallocating some parts of your view. And the simplest way to do this is to use this depends on. And you can say, so you fill this in. You say, actually, this part of the view only depends on the count and the step in the model, and we get those called count and step, and then you have your part of your user interface here, and if things haven't changed, then it will just use that last part of the interface description, and you don't need to reallocate anything. So that's pretty good for making it fast. So recycle subtrees that are unchanged, and unchanged subtrees are not diffed. Okay, so in the last part I want to talk about more work in progress in Fabulous. And it turns out that you don't have to use depends on for many situations, but depends on is fast enough for most information apps. But we can do even better by treating views as adaptive data So what we're really trying to do in this is you recover incremental data binding, but in the context of MVU. It's still kind of sticky in something that we recognize as MVU, because MVU is so simple and easy. So we want to still feel like we're doing functional programming, but we still want to get this sort of incremental update. Okay, it goes back to that slide I used earlier. Your UI is an incremental computation. And the question is, what happened to the deltas on this side? Because we're still doing this full view reevaluation from the model to the VDOM every time. We've kind of lost part of our increments here. We really want this whole part to be incremental as well. Okay, so how do we do that? Well, we need to build on a notion of incremental data. We need some, because when you define data types like arrays, they're not incremental by default. Okay? Or if you define classes, they're not incremental. You can make mutations to them, but they don't give you a notion of change that you can get your hands on. And so we have this library called FSharp.data.adaptive that brings right down in the core of your FSharp data model, allows you to use incremental data. It gives you the building blocks for incremental data. So FSharp immutable data, as you're totally used to using it, but where you get these event sourcing, or if you get these incremental differences up through your data all the way through. So, for example, if you had a pipeline in FSharp where you're doing a list.map, a list.filter, and a list.sum, okay, then there's a corresponding pipeline over adaptive lists where you can do an adaptive list.map, adaptive list.filter, and adaptive list.sum. And the key thing here is if the list changes, say by inserting an element into the middle of the list here, well, you can map it. You can also filter it to check whether that element is still in the list. Yeah, but in the top pipeline, you actually have to reevaluate everything, okay, because that's how list.map works. If the list has changed, it had better go back and work all over again. There's no incrementality if there's an insertion. Whereas with the bottom thing, this adaptive list, if there's an insertion into the ultimate source of then, well, you just run that one map function, that one filter function, and if it survives through the filter and you get the sum, well, it'll just adjust that sum up or down because it knows that it's in the middle of the list. It doesn't really matter if it's in the middle or the end because you're doing a sum. And then, so you'll just do one. So if the list has 1,000,000 elements, then you've done 1,000,000 times less work, okay, in this adaptive. It's really vastly more efficient to use these adaptive data structures. But the aim is to make it look like functional programming, even though the actual data structures are actually adaptive. Okay, so where you're used to using an integer, you use an adaptive value that's an integer. Where you're using a list, you use an adaptive list, set, map. Where you use a syntax 1, 2, 3 to create a list of 3 elements, you'll use an adaptive list 1, 2, 3. If you had something that worked with time, say 1.0 plus now.seconds, yeah, well, this is not really immutable because time changes here. Well, over here, you'd create an adaptive value which took the current time, depends on the time, and returns the overall result. And the pipeline, if you had the map filter sum here, you just modify it to use adaptive list map filter sum. Okay, so once you have adaptive data, you can now use that in your views. It's going to be a modified variation of Fabulous, and this is what I'm working on at the moment. It's called Fabulous Adaptive. You'll see that namespace at the top change. So this is the non-adaptive, and I want you to imagine we have got a view with a content page, stack layout, an image, big long list of items, and a button. And imagine that this model.items has 1,000,000 elements in it. Or it's 1,000,000 dots on a chart or the like. Then when there's an update to model.items, if you're reevaluating the view, you have to reevaluate 1,000,000 points in your user interface, and that's really not what you want to do. But in the I want you to see how small the change is to get to the adaptive version. We put in some C's, we'll talk about those in a moment, but we replace our list with an adaptive list. And we're using, and the thing that we're creating is an adaptive view. Okay, so there's the change to make the thing 1,000,000 times faster. Okay? because here we've got it fully incremental through adaptive data. Because when there's a model.items gets inserted in the middle, it'll only run that one extra thing in order to generate the new label and insert it into the view and modify the underroll. It's very magical what's happening here. You do have to mark up the parts that don't change at the moment in the prototype we have with C or CS up here. That really means constant, not changing, whereas this part is adapting. See which parts of your user interface will change over time. And if only one item is inserted, then one update is ultimately made. You've got incrementalization all the way through. Okay. So it's really magical, I think, what we have coming together there. I get back to what I mentioned about Fabulous Contacts. If you want to learn how to use it, then it covers all these different topics: sending SMSs, multi-page apps, asynchronous loading of data onto maps, and taking photos, splash screens, and all the things you need to do on good user interface design, some of them. There's lots of pragmatics covered in the Fabulous documentation: animations, state persistence, time travel debugging, live editor tooling, how to reduce your app size down to something small so you don't get the whole Fabulous framework linked in. It just slices it down. And how to deploy and adding extensions for your favorite Xamarin Forms libraries. Okay, so I can finish up now and just say, to summarize the key points I've made. FSharp is about clear, as it has always been and always will be about, it's about clear code, solve real world problems. I did say we didn't have a strong point on user interface programming, and you can see now that we're starting to get that. MVU makes functional programming extremely relevant to the user interface. Most of you here probably think functional is not relevant, at least before you saw this talk. I hope I've convinced you that the world is heading in a direction where functional ideas are more and more a part of how we think about user interface implementation. I'm not saying it's how we think about user interface design. That's a different side of things, but in terms of implementing the information flow in the user interface. Fabulous is one example of an MVU framework. Fable-Elmish is another in the context of FSharp, but there are many others, and you'll probably start to encounter more and more of these in your work. And it brings this to this cross-platform apps. And this last thing I'm working on, which I'm calling Fabulously Adaptive, makes this sort of thing fully incremental and recovers really high performance for very data-intensive user interfaces. And there's some fabulous apps over on the right. And that's all I have for you. Probably coming 5 minutes short, so thank you very much.